Okay, so this is the how-to video for building your automatic nightlight, which is the circuit that you're going to build in lab this week. The LED nightlight that you built last week stays on all the time, and since it stays on all the time, it's wasteful of battery power. So what we're going to build this week is one that has some electronics in it that are going to cause the nightlight to turn off when it's light outside, and it'll only turn on when it's dark. So I'll go ahead and shut off the light in the room, and you'll see that the LED comes on. Okay, so the light or the sun comes back, and then the LED should turn off. So that's what we're after here. You can also, by the way, simulate nighttime by using your finger to cover up this little photo detector, and that'll cause the LED to turn on. So what you see are the completed circuit here, and then this is called the electronic schematic. A schematic is a drawing of an electrical circuit. And so what I'm going to do first is just sort of walk you through how this works and point out the different components, and then I'll go ahead and I'll build this so you can see me going through the steps to build it. So let's take a look first at the circuit itself. You see we have a 3-volt battery, which is powering everything. So all the energy comes from that. And then you see our 3-volt battery pack here. Now notice that the positive terminal of the battery pack, which corresponds to our red wire, is connected to this line up here. That's called the positive voltage rail. And then the negative terminal, which is the black wire of the battery pack, is connected to this line down here, which is the negative voltage rail. And so on your breadboard, you have up here underneath this red line, you have this entire row here where you can plug in wires and they'll all be connected to that red wire. That's the positive voltage rail. And then down here, you have the ground or negative voltage rail. Okay, now let's just look at the components. So over here, we have the RGB LED, which you're already familiar with. I've shown it here where I've got a 100 ohm resistor going between the what's called the anode of each of the LEDs and our 5 volts. Now in the actual implementation, I'm only using 2 resistors because I'm only lighting up the red and the blue LEDs within that RGB LED. That way I can get a combination of red and blue, which gives us magenta. If we were to put a resistor in for all of them, then it would glow white. But so you can choose the color that you want this to glow by choosing the right mix of resistors and choosing which segments of the RGB LED you want to light up. Okay. Now the purpose of all of this circuitry in here is to just turn on that RGB LED when it's dark out. And so the way we do that, the kind of the heart of this circuit is this device here. I've labeled it RCDS. That's this little device here. That's called a cadmium sulfide cell or a photocell. And what it is a resistor that can detect the presence of light. And so we have this configured in a circuit where I have that photocell. I also have what's called a variable resistor. That's this device here. And we're going to be using that to adjust the sensitivity of this later. I connect the point midway between these with a 100 ohm resistor. That resistor is shown here to the base of a transistor. This little black device here is a transistor, and a transistor is a device that has 3 terminals to it. They're called the base, the collector, and the emitter. And here's a drawing of one of those transistors when it's just sitting on the table. There's a flat side and then there's a rounded side. And so I drew this so that you'd know when you put this on the table and the flat side is facing you, you access the 3 terminals: emitter here, base in the middle here, and then collector here. Okay. Then the only other thing we have in the circuit are these wires. Now, when I built this one, for neatness, I've cut those wires just to the right length so that they can provide a connection across the circuit board. But what you're going to be doing, at least initially, is using some of the longer hookup wires that you have. It'll be a little messier, but it's quicker to assemble it that way. So The parts for this, you'll find most of them in your little circuit bag that you have in your kit. You'll find well, you're already using an RGB LED. If you find that the wires on that are too bent up from the previous work you've done, just come and ask someone on the teaching team. We'll get you another LED. But the transistor, the resistors, this variable resistor, you'll find those in this little kit bag. The CDS cell, we have to give you one of those at the beginning of class. Okay, the parts that we need. What I'm going to do is pull apart this circuit, and then I'm going to rebuild it. So the battery pack. So here's the battery pack, and we know we need that. So that's our battery pack. Okay, a 100 kilo ohm variable resistor. That's this little device right here. Now the thing about this is it has 3 leads on it, 1, 2, and 3. And again, remember, you're going to get this right out of this little bag here. We're only going to be using 2 of those leads. We're going to be using the middle one and either the one on the right or the one on the left. And so when we plug that into our circuit board, it's only 2 of the leads that we're going to be using. But that's that 100K variable resistor. Now it's variable because you can adjust its resistance. And we're going to adjust it so that we can make this circuit more or less sensitive to ambient light. You have a little trimmer tool that has a little slot like a screwdriver, and that can fit right in here to adjust this. I'll show you that later on. That's our trimmer tool. Okay, we need a photo cell. That's this one right here. Okay, and then 400 ohm resistors. In my circuit, I've actually only got 3, as I explained, because I'm only illuminating 2 of the 3 lights in the RGB LED. Okay, I need that RGB LED, and mine isn't too bad. It's not too bent up, but you may find that just from working with yours last week, it's already kind of mangled, and in which case you can go get another one. Okay, the small 2N3904 transistor. That's this little device. It's in your bag, and it's got a flat side, and then it's got a round side. And when you're looking at the flat side, it's got 3 leads on it, and they're labeled E, B, and C with reference to this drawing, E, B, and C. And if you've got good eyesight, which most of you have, you should be able to see that there's actually a number printed on there. It's 2N3904. It's hard to see that in this video, but that indicates the kind of transistor that it is. Okay, and then 3 or 4 wires. I'm building this one here with just 3 wires. I'll pull these small ones out, and we're going to build it with the kind of hookup wires that you have in your kit. Okay, and then the breadboard. So I'm going to go ahead and build this thing again. Now, a word about breadboards. If you look at the circuit drawing, by convention, we have our positive voltage up on top and our negative voltage from the battery on the bottom. The positive is red and the negative is black. And so we're going to keep the breadboard oriented this way, where we have the red line on top. If I spun it around, that would be the blue line on top, which would be our negative terminal. We don't want that. That could confuse things when you're trying to debug this. So orient the breadboard this way. And I'm going to plug in the battery last. You just sort of supply the power last thing. Okay, so the very first thing I'm going to do is I'm going to put in this little device here. So I'm going to get, that's my variable resistor, and I'm just going to plug it in, just like that, right into the board. I've left a little bit of room right in back of it because I have to connect one of those wires to my positive voltage rail. So I'll do that. Okay, so what I've just done is I've put this resistor in and I connected one of the leads to the positive voltage rail. The other lead, this one right here, that has to connect to one end of my photocell, my cadmium sulfide photocell. And the other end of that photocell goes to ground. So I'm going to take this, and I've already kind of pre-bent it to the right length, more or less. I'm just going to connect that to ground. Okay. So now I've finished this part over here. Now I need a 100 ohm resistor, and then I'm going to go into the base of the transistor. So I'm going to pick up my transistor. And when you take it out of the bag, you'll find that the wires are kind of close together. You want to bend them apart just a little bit, just so that you can get that transistor into three of these holes. And then you can put it wherever you want on the board. But now I have the transistor there, and I have to wire it up. So I have to get a 100 ohm resistor to go from this point to the base of the transistor. Now, where's the base? The base is this middle wire of the transistor. So I'm going to get a 100 ohm resistor. This part's a little tricky. I'm going to put it right in here. And then I'm going to go to the base of the transistor. Now I realize with me doing this with my hand kind of blocking it, it's hard for you to see it. But there it is. I've put that resistor in there. So I have just completed this part. Okay. And then I have that 100 ohm resistor it's going to this node that's connecting these two together, and it's also going into the base of the transistor. Okay, what else? The emitter of the transistor has to go to ground, and so the emitter is the leftmost lead. So I'm going to get a black wire. Now, let me tell you something about the colors of the wires I'm using. By convention, anytime we have any wire going right up to this positive voltage rail, we use a red wire. If you run out of red, you can use orange. And anytime we have a connection that's going directly to ground, we would use a black wire, or you could use a blue wire. So that's going to go to the emitter of that transistor. So you can see that's the leftmost lead here, right there. Okay, so I've completed all of this part of the circuit. Now I just have to connect the LED. Okay, and I'm going to put that. I'm going to have this, the long wire of the LED. You know, if you look at this, it has one wire that's longer than the others. That's called the common cathode. I'm going to put that down here. And then the other three, I'm just going to plug into some holes there. Okay. So I have to connect that common cathode, that's that long wire, is going to get connected to the collector of the transistor, and the collector of the transistor is the rightmost lead. So from that rightmost lead, I'm going to go into this column, which will connect to the collector, which will collect to the common cathode. Okay. Now I have to, the other ends of the LED are going to go to these 100 ohm resistors, and then up to 5 volts. And I'm only going to put 2 resistors in because I just want to light up the red and the blue to get a magenta glow. So there's one of the resistors, and I've already pre-cut the resistors. That just makes it a little neater for you to see on this video. The resistors that you're using are going to have a longer lead on them. That's okay. It's just a little messier and a little harder to read. Okay, now assuming I've built everything correctly, I should be able to hook up the battery. And this should work. When I cover this up, the LED should glow. Okay, there it is. Okay, so it will glow when I cover it up. And if I put out the lights in the room, okay, it's so now you can see it's glowing partially, but I still have some of the light on. I have light from one of these lamps on. So right now this is a little bit, I have to make this more sensitive. Let me show you. If I turn this light off, now I've got it glowing. But I don't necessarily want it to glow in this condition when there's a light on. So what I'm going to do is I'm going to actually make this a little less sensitive. I'm going to turn this clockwise until that light goes out. Oh, I'm going to turn it counterclockwise. Okay, it is out. The reason why it looks like it's glowing is that's just a reflection of the overhead light. Let me show you when it turns on. All right, there it's on. All right, it just turns off there. But I'm just using this, and I'm turning it a little bit so that I can make it less sensitive to the light in the room. Now, when I go ahead and cover that up, then it comes on, okay? All right, so that's our circuit. And what I'll do is I'll just sort of tilt it a little bit so you can see it from different views. Now, on the course Moodle site, I've also got a number of still shots of this taken from different angles that you can look at. Okay, so there's our circuit.